fixed beam. So in earlier lectures, we have gone through the prop cantilever. Now in this video, we will be going through the fixed beam, how to analyze the fixed beam, and how to solve fixed beam problem. So fixing moment or the fixed moment is to be calculated, and then accordingly the problem is to be solved. So if we just look at the fixed beam, let us take a condition. The first one, that is concentrated load at the center of span. So let us consider there is a fixed beam like this, and there is having a load of W. Let us consider this is L, point A, B, and C. So this is L by 2. Now since this is W, so you will have this RA will be equals to W by 2. Then RB will be also equals to W by 2. And here you will get the moment, friction moment you will get. So let us consider this as MA, and let us consider this as MB. So if we just consider this that load W, which is acting at the middle portion. Now what we need to do, we need to just remove the fixed end and consider it as a simply supported beam. Now if it is a simply supported beam subjected to point load, then we'll have many moment diagram as a triangular in shape like this, the plus sign, and this would be WL by 4. So this is called as simply supported bending moment diagram. Now in case this is due to considering simply support at end. Similarly, bending moment diagram due to fixed end moment would be like this. If we just consider fixed end moment, so this is BMD due to fixed end moment. So here considering only fixed end. So this is simply supported bending moment diagram. This is bending moment diagram due to fixed end moment. Now if we just combine both the diagrams, so in that case we will get the combined bending moment diagram will be like this. So this would be positive, this is negative, WL by 4. Here this would be MA, this would be MB, and that is equals to WL by 8. So how do we get this WL by 8? So if we just consider that moment of M by ER diagram, so if we just consider, since the beam is simply supported, if we just consider that the beam is simply supported and we get the bending moment diagram, and if only fixed moments are there, and then we get the bending moment diagram. Now because of this M by ER diagram is to be considered. So let us consider that area of simply supported and area of fixed and condition, that would be 0. Now in such case, this is WL by 4. So area would be WL by 4 into L by 2. While because of this, MA plus MB into L by 2, which is equal to 0. This is area. Because of this AI is this one. So we have just calculated the area of this bending moment diagram, and now we will get therefore MA plus MB would be equals to minus WL by 4. Now since MA is equals to MB because they are symmetrical, therefore we can write MA which is equals to MB, and that is equals to minus WL by 8. RA is equals to RB, and that is equals to W by 2. So now consider bending moment at X from point A, and between A and C we will get Mx will be equals to W by 2 into X, and then minus WL by 8. So this is going to be WL by 8 into 4x minus L. Now therefore, we know that at point of contraflexure, Mx is 0. So therefore, we will get WL by 8 into 4 into 0 minus L, which is equals to 0. So this is going to be x. So in that case, if we just solve, we will get x will be equals to simply L by 4. Now if we just put the value of x equals to L by 4, so we will get maximum positive bending moment, which would be at the center. This would be equals to W into L by 4 minus W into L by 8, which is equals to W into L by 8. So this is bending moment, maximum bending moment WL by 8, and maximum negative bending moment would be equals to minus WL by 8. Now here there are some points you need to understand, and the first one, the total area of M by EI diagram is 0. Then moment of, you need to calculate the moment of area of M by EI diagram about any support is 0. So this is what we have to keep it in mind. Now let us consider another case. Uniformly distributed load of intensity W per unit length throughout the span. So if we just look at the diagram, this is the section, and there is UDL over entire span, W per unit length. Let us consider this is A point, this is B point. Distance is L. Because of the friction, you'll have the moment MA, MB. RA would be equals to WL by 2 and RB would be equals to WL by 2. It will be same because W into L is the total load divided by 2 at the one part, WL by 2 to the another part. So here we need to consider this as simply supported being subjected to UDL. So we'll have the bending moment diagram like this, parabolic, and this would be WL square by 8. Due to simply supported. Similarly, fixed end, if you just consider the fixed end only, so just like the last case, we'll have this MA. So this BMD due to fixed end moment. So FN, that is the fixed end moment. And if we just combine these two diagrams, so in that case, we will get like this. So this is BMD combined. So now we need to consider M by ER diagram. So AS plus AR, that is going to be 0. So AS is of for simply supported, AR is what fixed end. So we have this parabolic shape. So parabolic shape area would be 2/3 into WL square by 8 multiplied by length, and then this one is the rectangular. So we have MA plus MB into L by 2. This is going to be 0. So finally, if you just calculate MA plus MB, that is going out to be so if we just solve it, we will get minus WL square by 6. And we know that MA is equal to MB. Therefore, MA would be equal to MB, and that is going to be minus WL square by 12. So that will be half simply. RA, RA and RB, they are WL by 2. So again, let us take a moment at distance x. So mx would be equal to WL by 2 into x, W into x square by 2 minus WL square by 12. So if we just consider moment about this part, so we'll have because of RA, because of this load and this moment. And at point of contact flexure, Bm bending moment is equal to 0. So therefore, WL by 2 into x minus WX square by 2 minus WL square by 12, this is going to be 0. And if we just solve this, so this is going to be x square minus Lx plus L square by 6 is equal to 0. And therefore, finally, we'll get x equals to 0.212 L, or x will be equal to 0.788 L. So if we just calculate bending moment maximum positive, so this will be equal to WL square by 8 minus WL square by 12. So this is basically at the center Bm max. So we have this WL square by 8 due to parabolic and WL square by 12 due to fixed end moment. So finally we will get WL square by 24. So this is going to be WL square by 24. This is at the center. Bending moment maximum negative would be WL square by 12 minus, this is at the support. So this is what we have already calculated.